Hi. So here we have, suppose k is any integer such that this equation, the quadratic equation, has no real roots. Now when do we have a quadratic with no real roots? What is the condition for that? The condition is that the discriminant should be less than 0, right? So we'll apply that condition here, that the discriminant should be less than 0. And for the other quadratic, x square plus k minus 5x plus 1, this has distinct real roots. So what is the condition for distinct real roots? The discriminant should be greater than 0. So these are the two conditions that we need to apply over here. Okay. So let's start with this. The discriminant of this quadratic 2x square plus kx plus 5 is 0. The discriminant here should be less than 0 for it to have no real roots. So the discriminant will be b square minus 4 times of a into c should be less than 0. So k square should be less than 4 into 10, 40. So if k square is less than 40, it means k is less than plus root 40 but greater than minus of root 40. Root 40 is approximately 6 point something. So k is less than 6 point something but greater than minus 6 point something. Right? So what are the values that k can take between minus 6 point something till plus 6? So k can be minus 6, minus 5, minus 4 so on till 0, 1, 2, 3, 4 so on till 4, 5 and 6. Right? So these are the values that k can take. Fine. Now coming to the next quadratic, the next quadratic we have is x square plus k minus 5 into x plus 1 is equal to 0. Now for this quadratic to have distinct real roots, d should be strictly greater than 0, not equal to 0. It should be greater than 0, right? So if d is greater than 0, that means b square, which is k minus 5 whole square, minus 4 into a, which is 1 into c, is greater than 0. So k minus 5 whole square is k square plus 25 minus 10k minus 4 is greater than 0. So we have k square minus 10k plus 25 minus 4 is minus 21 is greater than 0. Okay. Sorry, this will be plus 21 actually. Right? 25 minus 4 is plus 21. So now this can be factorized as, or the middle term can be written as, minus 10k can be written as minus 7k minus 3k plus 21. Basically the two numbers whose product is 21 and the sum is minus 10 are minus 7 and minus 3. So once you split this and once you factorize it properly, you'll get k minus 7 into k minus 3 is greater than 0. So we have this comes from inequalities. If k minus 7 and k minus 3 is greater than 0, the critical points here are 3 and 7. The critical points are basically when the left hand side or this expression becomes 0. This becomes 0 when k is 3 and this becomes 0 when k is 7. So if you take k greater than 7, if k is greater than 7, this whole expression will always be positive. Hence value of k greater than 7 is acceptable. What if k is between 3 and 7? If k is between 3 and 7, this number here will be negative and this will be positive. So the whole product will become negative. So we will not accept this range for k. K cannot be between 3 and 7. If k is less than 3, this will be negative, this will also be negative. So negative into negative becomes positive, hence greater than 0. So even for k less than 3, the expression is positive, hence we will accept this solution. And when k was greater than 7, both were positive, hence this was also acceptable. So the acceptable value of k from the second case is k can be less than 3, that means from minus infinity to 3, union from 7 to infinity any number. So these are the acceptable values for k from the second case. Now the total, we want integral values only, right? So we want this to be true as well as this to be true along with integral solutions. So basically we have these integers and we have to figure out how many of these integers lie in this range, right? So we have minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5 and 6. All of these were the acceptable solutions from this case, and out of this, if you see, the numbers from 3 to 7 are not acceptable, including 3 and 7. So 3 is not acceptable, 4 is not acceptable, 5 is not acceptable, 6 is not acceptable based on this range. So any number less than 3 till minus infinity, all these numbers are acceptable. So how many of these numbers are there? 6, 7, 8, 9. So there are 9 numbers or 9 values of k which are integral and satisfy both this as well as this quadratic. Hence option C here is the right answer. Thank you.